Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
The last show from the terrarium.
Yes, here we are in the people terrarium.
The people terrarium.
You got a little moss on you there, dude.
I didn't shave this morning. Sorry.
You're not the only one.
Yeah. And Paul Yuck is here. Andrew Hall is here. We're going to be talking Azure, of course. And but first, we have this little thing we have to do called Better Know Framework.
Awesome. All right, man, what do you got?
I am also talking Azure.
I appreciate that. I like your symmetry. I like I'm picking up what you're putting down.
And I hope that I'm not stealing some thunder here, but when we talked to Scott Hunter a few weeks ago, or a couple weeks ago, depending on what your perspective is, he told us about Azure SignalR service.
Yeah, you've got to love this.
And
you are the SignalR guy.
I went nuts. I was like,
Nice.
This is so great. I mean, not that it's hard setting up an ASP.NET website and, making the hub and all of that stuff. It's not hard. But what happens if it gets really popular? Now you got to start thinking about backplanes, and you got to start thinking about scaling it and all that stuff that goes with it. Yeah. Why don't you guys just do that? So that's exactly what this is, a fully managed service.
How about you do that? Just let you do that.
Fully managed SignalR service, and you just deal with the JavaScript or the C# or whatever you want, whatever language du jour you want, and go to town. Instant, real-time, persistent connections.
Yes.
Yeah.
We need to use it more, too.
Yeah.
I'm always happy when Microsoft takes those libraries they provide to us and they put them in their own products. A, they get better.
Yep.
B, we're pretty sure they're going to stick around.
Yep.
And you get to see some real examples of what's possible, because usually you're able to stress
our tools
it really
would
well.
really benefit from that.
Yeah.
We're refreshing all over the place. And
Right.
We use this little admin
better.
client for managing .NET Rocks episodes, so how we take notes and keep track of various things and so forth. And is it SignalR under the hood?
It is SignalR under the hood.
Yeah.
It took me literally an hour to do. And essentially what happens is, as you're typing in a field, it just updates
Pops
on
it over to
whoever
me.
else is logged in and looking at that data.
And it stops us from stepping on each other. That we can both be taking notes and things, and we can literally see each other's notes.
It solves the concurrency problem
nice.
that is, has plagued programmers since the dawn of databases, right?
Yes.
Who's going to get there first? Well, it doesn't matter, because
We're both there.
We're in sync.
I just like to lock Andrew out. That's my strategy.
That's cool.
true.
It's going to be that kind of day.
The pessimistic kind of
There
lock.
you go.
Yeah. Well, that's what I got, buddy.
I love everything about that. That's awesome.
Yep. Who's talking to us, my friend?
Grabbed a comment off show 1467. So dipping back to August of 2017, a show we did about the Azure platform landscape with Barry Lubrix. Now, I hope I pronounced your name properly, Barry. He's our Dutch friend who helped me out a bit with Humanitarian Toolbox in the Netherlands, and had a really good story. Just started talking about, and again, admittedly a year ago, because you guys change this every couple of weeks, sort of what the Azure landscape looked right at that point. And I thought this particular comment was pretty powerful, because I think we're going to address it. This is from Majid, who said, and he only wrote this 5 months ago, "Thanks, guys, for the informative and entertaining podcast that I've been listening to for years. This was a great show that summed up a lot of the Azure services. However, very little has been said about debugging Azure services. I only deal with app services and storage alone, and sometimes the debugging can be really tedious. I've seen people doing different things, like spinning up a computer node to capture a trace and then throwing that into a storage account. Application Insights is still a bit messy and slow. One instance, the VS started up an Insight resource, and the app service started a different one."
That's always a good day.
"There is a need for an easy trace method. I did create a SignalR method that writes traces to the browser console, and I called it from a static class, and it gets that trace from anywhere in the application, and that solves a lot of problems, but seems a bit bizarre. And I think about sort of modern, or maybe old school, like in the DNA days, App Dynamics and things like that. They built these kinds of tools and charged a ton for them to follow that sort of transactional path from the web page to the app service to the database and back again. Those are complicated, and I think it's almost exactly what Majid is describing there.
I feel like so many companies out there invent their own correlation scheme.
Yeah.
And even after you do it, which is a bit of a daunting thing.
Yep.
Then you got to get everyone to use it.
Mm-hmm.
And it turns out that the people problem is almost harder than the technical problem.
Right. Just make sure you pass this token along in each layer. Make
Right.
sure it's in there. Yeah, sure.
Like
all those
any
different
broken
teams.
link, it's kind of like my Christmas lights that never work.
Yeah. And Majid goes on to say, one bad light ruins the whole string, right?
One goes out, they all go out.
There's good Christmas lights. I never managed to buy them. I have only the bad ones.
Only bad Christmas lights. Majid goes on to say, I start thinking about other services like the Active Directory and Cosmos DB and the IoT hubs, and I'm going to need some better instrumentation if I'm going to buy into all this Azure ecosystem. I remember in one show, Richard said something about reducing the cycle time of debug, change, and redeploy, and that pace sets your productivity.
Right.
I hope that Azure is paying attention to the same sort of cycle when it comes to debugging services. Maybe I'm missing a lot, but I sure would appreciate a show on figuring out those kinds of problems.
We'll have plenty of time to talk about that today.
Yeah, and plenty of good conversation to have in that area. I think it's important. So, Majid, thank you so much for your comment. A copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .netrocks.com or via any of our social media. So we publish every show to Facebook and Google+. And if you comment there and read it on the show, we'll send you some Music to Code By.
Yeah, absolutely. And follow us on Twitter. I'm at Carl Franklin. He's at Rich Campbell. Send us a tweet. Keep them in sync. Signal our
Nice.
Azure services.
WebSockets are your friend.
Yes, that's right. No, not really. Let me just formally introduce Paul and Andrew. Paul Yuk is in Yuknewicz, right?
Yes.
Yeah, but we call you Paul Yuck.
Yeah, and I like that.
Yeah,
My
Paul
friends,
Yuck.
my friends call me Yuck.
All right, Yuck. Yuck is the Principal Group Program Manager for Azure Tools and Diagnostics, and Andrew Hall is Program Manager Lead for .NET Web and Azure App Service Tools. So you guys are just the people to answer that debugging question, aren't you? I know you're just raring to go. On that.
I can answer parts of it. I think there's some good subtleties to that raise too. So you get to think through that.
Sure.
Yeah.
But being able to trace connectivity behavior between various platform pieces, that's not a small problem. And
No, it isn't. And we need to help with that.
Yeah.
The we being even Microsoft and Azure, right? Because you're hopping through code that you own and deploy. You're working with infrastructure that you no longer own and deploy. Right. That's like a cool thing about managed services.
Yeah.
And then you even exit the realm of code into things like messaging, like you brought up events, right?
Yeah.
Whether it's Event Grid or Service Bus or storage queues, IoT Hub, all those things, all the way around. So if I'll jump into it. One thing, we want to make sure that correlation IDs are available through all points of the transaction, so that simply the same correlation ID can be used to search and pull an entire transaction back up in order and show you what happened, ideally at like the provenance of when something happened.
Yeah, a sense of how much time was spent in each layer.
How much
and
time.
where the error message actually popped,
That's a good point too, yeah.
We kind of see it at the end of the path.
Yes.
Many you years ago, I had a customer tell me, I want you to get this ODBC stuff off all my machines because all it does is cause errors.
Yes, I love it.
Well, we could suppress those pesky error messages for you.
You hit just all kinds of things in that one statement, right? So one is, I want to just understand a bit of the anatomy of my transaction and just understand what's going on,
what
how it
pieces
works,
were involved.
Right?
Yeah.
And a lot of times when I see people diagnosing things, they either draw a picture of the components or they draw this kind of sequence diagram. They're trying to understand at what point could things go wrong and brainstorm what it could be.
Right.
And so a lot of our efforts with the tooling has been able to basically automatically create these kind of diagrams for you based on the data that we can see from the Azure service side.
Sure.
The next thing, I think you talked about both, there's like failures and there's also like performance degrade.
Sure.
And into the same picture, you're going to see both kinds of things.
Yeah. And both latency and processing time consumed, right?
Yes.
Sometimes it's just a bad connection and you blame it the stored procedure. Sometimes it's a bad stored procedure. No connection will save you.
Totally. And then whether you're in dev test or you're in production dealing with a live site issue, a lot of what we see is kind of the human side of it, where it's like, is this in my code or someone else's code or in Azure? And I'm trying to figure out pretty quickly which one it is.
Right.
So that everyone saves time and you move forward and you fix it, right? And so that's really that triage process. I think the correlation can help a lot. It's like trace the whole thing, see which maybe intersecting components seem to have the problem, and then isolate down to any hints that would tell you what's different or anomalous or are not good.
Right.
And then long story short, so what did we do? When you're using .NET, we automatically now add correlation IDs to requests. You think about .NET is usually the server that will handle an inbound request.
Right.
And then oftentimes you'll have something like a logger. So if it's .NET Core, it's what iLogger. If it's .NET Framework, there's a lot of options like System, Diagnostics Trace, or your favorite logger, maybe Serilog, something like that.
Yeah.
But we want to make sure that these correlation IDs are always present both inbound and the same one is passed through outbound.
And it's just
to make that seamless to you.
That
it's like a hashy GUID kind of a thing.
The whole series of stack.
Exactly.
Yeah.
So we call it a parent operation ID, kind of like the very beginning of the transaction as far as when we can see it, we would create the ID. And then once an ID is present, at every hop along the way, we want to pass the same one through. And if it's a web application, we just use HTTP headers. So we kind of do the pattern that I think a lot of people out there do themselves.
Right.
So we plumb that straight into .NET and then also into App Insights, because App Insights is something we control that the collective we that can pass the same correlation outbound.
Yeah, I would hope that this all lands in App Insights at some point.
It does. In fact, I think we want it in both, because there'll be cases where App Insights isn't there. There'll be cases where it is there. And App Insights isn't intercepting inbound requests, so you need the runtime still to help with that. At least technically, that's how we think about it.
Does tracing these IDs get tricky when you talk about concurrency and asynchronous parts of the same transaction?
Yeah, that's a great question. I believe it does. I think you need your runtime to keep track of which inbound request maps to which outbound requests.
Yes.
Right.
Yeah.
And so it's that kind of that one to many and making sure that happens. Because if you kind of think about it, you could approach the same problem kind of outside in and just inspect everything coming in and everything coming out almost like a fiddler kind of approach. But then without that mapping internal to the runtime, you don't know which outbound request actually came from which inbound one. And it turns out that matters. Like there'll be different inputs.
So now you have to keep an array of those things.
We do. We have to watch it at all times. And so that's basically what we're just being really careful that all inbound and outbound are going the same way. And they can be encrypted, which is a challenge.
Sure,
right? There's HTTPS.
And probably should be.
And they should be.
Yeah.
And they will be asynchronous because it's the web.
Yeah.
So I think you're hitting on a bunch of the hard problems that we had to deal with.
Especially you think about a big call to a multiple sets of async awaits, and
sure.
maybe your error only occurs with a particular order of return.
Right, that's right. One call may need to call another downstream service that is waiting on, and then another one is just going into a queue somewhere and going off and doing something else.
Yeah.
I think you told me one day, too, that one of the hardest problems you hit, you could only see under an incredible amount of load.
Yeah, that's one of my favorite
resource
stories.
contention.
It was a deadlock story about SQL Server, right? And the only time it happened was at peak load, and it wouldn't happen any other time. And so I got to a point where literally we were going to turn on SQL Trace during peak to get a copy of the transactions that were going. Like, you mean the stupidest time to turn it on? Well, yes, that's the only time we're going to need it. And the joke, of course, is when I finally clear enough disk space, it's going to generate gigs of files and so forth, and we're watching all this, we turn it on, error doesn't occur. And it's because the weight of the tracing altered the timing just enough to make those deadlocks go away.
It truly is the inspection effect, right?
It's absolutely. You're absolutely seeing the observer effect in action.
Effects,
And of course, the developer's reaction was, well, leave it on all the time. Just delete the log. But it gave me the hint that literally led to, I started inserting 1 second waits into stored procedures.
Wow.
And eventually found out it was the timing between two interacting stored procedures.
Wow.
That was that subtle. It was just one of those crazy things.
Yeah, that's perfect.
You're doing do events in stored proc.
I was do eventing in stored procs. Yeah,
that's awesome.
It's a special kind of hell.
And I think that's exactly hitting on where we want to go next with this. So Azure has insights into the infrastructure and what's going on at the time, and there's metrics and activity logs for all of that. And then also in your application, you have these logs, and we want to now better correlate between the infrastructure and the application. Just to understand if there's something else that also happened at the same time that could have been affecting the bigger picture, right? So like if it's resource contention or a deadlock, let's take the case of a container. Knowing that your containers were being recycled 200 times when this was called would probably be useful when you're diagnosing the request.
Yes.
Yep.
And today, the data on its own will be siloed. So, so basically, like step one, we put correlation everywhere. Step two, we built these, like we call them distributed end-to-end trace views, but we show this almost Gantt chart over time from hop to hop to hop and how much time was spent and where the actual error was. And then you could map those like internal 500 errors all the way to the actual exception where the bad data, where it actually started. And then I think, step three is kind of this now overlay over it Azure's understanding of what is also going on and see if you can find deeper problems.
That's awesome.
Yep.
Well, talk about answering somebody's comment to the show, and it's not actually what we were going to talk about today, although clearly part of Azure
tooling. I didn't get to debugging, which is like,
it's one of your favorite topics, I know personally, Paul, but it is certainly part of Azure tooling, right? Like Azure is Azure, and then the platform's play is getting better all the time. Like we've got great offerings here, but what Microsoft's known for is the great tooling that makes it easy to take advantage of this stuff.
Yeah,
right.
So. Yeah, my boss he calls it developer experience because we found a lot of times just to focus on the developer, we actually have to go work deep in the runtimes and deep in Azure to make the tooling rock.
Yeah,
right.
Yeah, well, I think that's a really interesting reality that as you start to understand what tooling you need, you also realize you need to change Azure itself.
Yes,
right. The two kind of go together. So, no way around that. It's just the thing.
So, Andrew, how are you?
I'm doing great. Watching Paul do his thing.
Yeah, how'd you like the show so far?
Paul gets an A.
Oh, very good.
Did you know Andrew actually worked on the core debugger?
Oh, wow.
Wow, awesome.
I did. I spent 4 or 5 years working on the Visual Studio Core debugger.
Wow.
And to your point, almost anytime we wanted to do something interesting, we had to go work with the .NET runtime to get features in .NET to make the tools be really cool and really performant.
It's usually you just don't have enough information. Like I don't know enough to say something meaningful here. Is that fair?
Yeah, that's fair. Or it's really slow to call 6 APIs and stitch the data together. Right. If we did something new in the runtime that has all the information and we could return it in one call, then that'll be significantly faster.
And we get back to that observer effect problem. It's so much instrumentation, so much diagnostic tooling affects the system so much you basically can't use it.
Yep.
And so it's always been a challenge to make that kind of stuff.
I don't know what you guys think in here. I often hear like the overhead maximum we're allowed to do for anything diagnostics and debugging total is 5%, 5 to 10%.
Yeah, I would say 2, but then I'd
say 2. Yeah.
I'm a web performance guy, right? Where we were super sensitive to those kinds of numbers, and the guys who the first guys I ever met that really got that were the preemptive analytics guys way back when.
Oh yeah,
they were really big on they would actually dial back their instrumentation as the load went up on the server. And we were always testing IIS right at the limit. Like I got really good at getting IIS to literally go around the drain.
Wow.
We're not going to go down. We're just going to hold you right at that edge there. And and sometimes what tipped it over was a diagnostic run. Like something would kick off and grab a set of values and go, off you go, right? That the request rate sort of starts to taper off there. Like this is the point where now it's going to start recycling the process over and over again and start to crack. But that's where we're holding it. And then all it took was a diagnostic burst to grab a data and it went, boom, down it went.
Our first profiler was like a very good node shootdown tool.
Oh yeah.
Yeah. So and then we had to reform and we got better. Yeah.
It's hard. Yeah. Absolutely brutally hard problem. So what is the new tooling that's being talked about here at Build? Like, what do studio developers need to know? Good things that happen.
Yeah, so we've kind of been incrementally releasing a lot of value since we shipped 2017, a little over a year ago. So I think we generally more have talked about the way that we've evolved the tools than necessarily one big giant announcement at Build. So we released our 15.7 update and our preview of the 15. Update on Monday of this week. So kind of gives you, that's the 7th and 8th update respectively as we've trickled stuff out. A few of the things that we've done that I think we're pretty excited about is we've just tried to make it easier for the developer to stay in Visual Studio when targeting Azure.
Right.
Less sending you to the portal to create things.
Right.
And then the other thing that's still relatively new, so we like to talk about it a lot because I think it's exciting technology and it's where you want to go because hopefully we don't need to pay Richard to make IIS perform for us in this world.
I don't do any real work anymore.
is serverless computing. So the idea that you simply provide individual functions and then Azure takes care of scaling them up and scaling them down as needed. And so we've been working on those tools. We shipped the first rev of them about 7 months ago, and we've been just incrementally improving them ever since.
Yeah, absolutely, Matt. Absolutely the magic thing. And guys, sorry to interrupt, but we do have to take a moment for this very important message.
Support for .NET Rocks is brought to you by Conversational UI from Progress Telerik and Kendo UI. Conversational UI are chatbot framework agnostic user interface controls and components that enable .NET and JavaScript developers to create modern conversational chatbot experiences in their web, mobile, and desktop applications. The industry's first packaged set of user interface components built specifically for chatbots are available as part of Telerik's ASP.NET Ajax, ASP.NET MVC, ASP.NET Core, WinForms, WPF, Xamarin products, and Kendo UI for jQuery, Angular, Vue, React, PHP, and JSP libraries. By implementing key UI design features such as calendars, date pickers, list views, and others that are included in the toolsets, developers will be able to improve chatbot conversation through visual elements. For more information, visit telerik.com/conversational-UI.
And we're back. It's .NET Rocks, Carl and Richard here at Build in Seattle, talking to Paul Yuck, Andrew Hall, and we're just started digging into the main topic today. For better or worse, I have nothing to complain about our initial conversation because it's really drilling into some important stuff.
Yeah.
And I'm feeling like, as much as you guys have done amazing things around containers lately, like, should we just be writing functions and just delegating the scaling problem totally to you guys? I don't even want to think about it. Just run my function and make sure my function always runs.
So it's a fair question. I think for the most part they solve different problems, and we would suggest that you use them together for what each one does well.
Sure.
So functions are great because you pay per consumption, but if you're going to have something that's going to be running constantly and under heavy load for like inbound requests, so you think about serving ASP.NET web pages, that's not really what functions are designed to do.
Especially
functions are much more event-driven for batch or job processing. So you think about running like a Kubernetes cluster potentially that would be serving your web front end. And if that's going to be under load, that probably doesn't make sense to run that as functions, not really event-driven at that point other than the HTTP requests coming in. But then as you're taking assets and uploads and things like that, and you're pushing them into queues or event hub, or service buses, event grid, sorry, not event hub, but things like that, then using functions to do all the processing, actually it's a good way to take some of that load off of the front end, so you may not need as many cluster or nodes in your Kubernetes cluster, for example, and so it'd be much more event-driven. So Paul and I gave a talk yesterday, which I thought illustrated the concept relatively well, that it was a basic app. It was just an ASP.NET Core application that the user would upload images. We'd push it into storage. We wanted to do some processing. There's a function that's queued up that whenever image goes into that blob storage, it picks it up, it does that processing. That's going to scale infinitely, indefinitely, but I'm not necessarily going to use just functions to serve my ASP.NET application that's going to have all the stuff that the user's interacting with.
Right, and for a website, it makes perfect sense to use the website, the Azure Web Service, because you get all that caching, for example. That's where you can concentrate all that power. But I totally agree with you. The functions are great for, the things that you might be using a web API for now. Just, service calls, microservices, things that do stuff and report back and call raise.
Or anything you'd be using a web job for today.
Yeah, web job.
Right.
Yep. Yeah. My first thought is to use it for like whatever you had a worker. Like something that would chew and do some work, and it might just take a span of time, and then it's sort of done.
And then it's done. Yeah.
That message has changed a little bit lately because Azure Functions, when they first came out, we were told, don't do any long-running processes in Azure Functions. And clients we're working with at AppVNext right now, we're doing, long-running functions, and there's a way to keep them going and keep them alive.
Yeah.
But that's the norm today, isn't it?
Yeah. And I think too, like maybe it's how chatty versus kind of chunky it is, right? Because if you hammer a web API, that might be a good case for an always-on kind of dedicated app service.
Yeah.
Where a function that it can do it, but then the consumption benefits, you're not really seeing that because it's it's effectively always on.
Sure.
Right. And they are sort of inherently stateless. You have to manage state on your own.
Yeah.
To me, it seems like there's only certain pieces. What I like about them is they're independently scalable. So you're taking a relatively small bite, and you don't know how much of that you're going to need to scale. So the fact that you don't have to think about it just does that. But there's huge tracks to your apps that aren't like that. That are sort of consistently scaled and are more monolithic or larger, and they're just not going to make good functions.
Yeah. And the financial benefit you get, the cost savings that you get if you do it right can be phenomenal.
It's amazing.
Yeah.
And the time that you don't spend operating and scaling that thing and patching it, it's very cool too. So other stuff.
Yeah,
some publish updates, right? Those
yeah,
cool.
we've worked really hard to smooth out the path of publishing directly from Visual Studio to Azure with the goal of, I'd like to say, assuming you have your Azure subscription, most applications, we'd like for you to be able to take that from your local machine directly into Azure in less than 2 minutes.
Right.
Because we used to have to download a profile and import it, right? Do you have to do that now?
You don't have to do that, so you can create it all from Visual Studio now. Going to Azure App Service, you mentioned containers. We give you the ability to provision an Azure Container Registry and publish directly to that all in one flow. If you provisioned that, you can go to App Service for containers, which will set everything up in both the Azure App Service and the Azure Container Registry, all as part of that flow.
Okay.
So yeah, for kind of an average web application on a decent network, you should be able to 2 to 3 minutes max while it provisions all your resources in Azure and copies up your binaries, and you should be able to have a running application.
Very good.
And so, to Paul's point, we've, focused a lot on just making that as smooth as possible. We redid the UI in our 15.6 update to try to make it simpler, easier to find additional services. So we give you the ability to create SQL servers and storage accounts as part of that in Azure. So if you have an application that depends on SQL and storage, you can kind of in just one, all from the Visual Studio UI, get everything set up, provisioned, and the connection strings will get into the right place, and your application should just work when it gets up into the cloud.
Yeah, it's great.
It is awesome stuff, and it is interesting to see the sort of mixture. Like, my biggest battle with Azure is just trying to sort all these different pieces out. Like, there's a lot, and I'm taking notes as we're going. So every time you name a product, I'm grabbing it, including in the links, and you rattled off a whack there. So, these container services, there's also the Kubernetes service. They're not the same.
The Kubernetes service is intended to replace the container services.
Okay.
So even today, if you go into the Azure docs, there'll be a big pink banner, I think it is, at the top for the Azure Container Services that says that this is being replaced by the Kubernetes service. We recommend you go over to those.
So Kubernetes is one.
Kubernetes is one.
Yeah, there's been a lot of different container orchestration services out there for a while.
Yep.
But what I notice about Kubernetes is, certainly runs on-prem, open source, but it's now a service in Google and a service in Azure and a service in Amazon.
Yep.
So
a managed service, no doubt. Yeah.
And as a managed service, like, you'll literally do the work for me. That's pretty interesting.
Yeah, that's pretty cool. And even on top of, I always look at kind of the strength of the ecosystem, and I feel like the ecosystem has really taken off this year, right? So if you're familiar with like Helm charts help you install stuff into the cluster.
And you guys bought Helm like a year ago or something.
Yeah, the Diaz folks.
Yeah, we didn't buy Helm, we bought Diaz.
Yeah, they like the expertise behind all of it joined. So there's folks like Gabe, and then there's Brendan Burns, who worked on Kubernetes. They're actually a part of the core team.
Yeah, right. Brendan Burns, he's an open source guy, but he came to work for Microsoft. So.
Yeah, so he's the dev director, and Gabe runs the PM team working on AKS. And so we have some of the core founders of the projects actually working here, which is really cool. We learn a lot.
What is Helm?
Yeah, so Helm is a way to use a template to basically declaratively install and get to a desired state of what's in your cluster. So let's say I want to have a sidecar running a particular logging agent. I would declare that in Helm. It's almost like a bootstrap or a package manager, but for a cluster.
Right.
Okay?
It's the manifest that describes how the cluster is going to behave. You configure ports. You configure what is publicly exposed versus privately exposed. Sure. So if you want you have your front end agents.
It simplifies the manifest, right? And it's also becoming kind of a unit of extensibility and sharing. So you see that a lot of common topologies or rigs or just app types are now described as Helm charts, and you can go recreate an entire distributed application using a Helm chart.
And I think it's worth mentioning, I can't remember if we said it or not, so apologize if I'm repeating it, but it's a templating language for then generating the Kubernetes manifest. So you could go author your Kubernetes manifest, right? And then I could check that in. And now when you want to change 3 things, when you go git clone my repo, but you're going to run it in your own cluster, you might. And so what Helm does is everything for the most part is a variable in the actual template, and then you have the ability, a values file, or the ability to pass in things from the command line.
Okay.
And so one thing, for example, we are trying to work on in Visual Studio right now, which we're working on getting to our preview extension to release, is we talked about publish, the ability to publish from Visual Studio directly into an AKS or Azure Kubernetes cluster. And what we're going to do there is, because we're going to know all the container registry information and the tag for your Docker image and all of that stuff, is we will simply then pass that in as command line parameters when we call the Helm.
Right. And so Helm uses this term charts because it's all going to be a nautical pun.
Yes.
Yep. Yeah. In the end, these are YAML templates.
Yes, YAML templates describing the desired state
that sort of set
of the application should be. And
interesting.
A lot
this
of times
is all configuration as code stuff, right?
It is.
Like, this is what how this app is supposed to live. But it also works equally well when you just fire it at a test infrastructure.
And it simplifies things, like you were saying too. It kind of reminds me of whether it's apt-get or Chocolatey. Like, it really abstracts some of the bigger chunks of stuff that you want installed, bigger components or servers. So it's easier to kind of construct that entire application.
Right. And the document you're building here is literally the code you run for it. So you know, you're not looking at a Word doc going, "Oh, that's wrong."
Yes.
Like, this YAML file is, pretty much just clear text set of statements. It says you need one of these and one of those and one of these and one of these, and open up this and set this, and
so it's kind of like the Docker file is to a container. What this is to a cluster.
To a cluster and application pod.
Correct. It's the same thing. It's a configuration at a bigger level, higher level.
I love it.
Yeah, and so we're building a lot of tooling, like you're saying, that understands not only Kubernetes but also Helm. So now there's an extension you can go get, and if you guys caught the Azure Dev Spaces demo, it was hinted at, it was shown very quickly, but you can create a new solution that's called a Kubernetes solution. Or you could take any existing web or server app and say, add orchestration, pick Kubernetes, and you're going to get these Helm charts, and then Andrew's tools kick in and can help you deploy them to Azure Kubernetes Service.
Nice.
That was Hanselman and Hunter that showed that, right?
Yes.
Yeah.
Yeah, I think it showed up in a few places.
Okay. Well, Richard.
Yeah, buddy.
Guess what time it is now?
It must be that happy time again.
Yeah, it's time to share the comment that I put at the top of every class I write.
Oh, what is that?
It says, "This code was generated by a tool."
Took him a minute. He got there. There you go.
Actually, that you used to see that in code-generated stuff.
Yeah,
you
sure.
still do sometimes, right? Actually, I love having to explain my jokes.
So you don't have to blame someone for
that
ugly code.
I have a burning question for you guys.
Yeah.
Remember the comment that used to say, "Put your code here"?
Yes.
Yeah.
Was that offensive or was that a good thing? Actually, I've been
is code
for almost
a code?
18 years. That's I don't know where I stand on it.
Does my code go here or not?
Yeah.
Can I put my code wherever? You can't tell me where to put the code. You're not the boss of me.
I could really see it going the other way. Some people are thankful. Someone finally told me
where to put my code.
Well, it's actually time to give away a D-Experience subscription from DevExpress to one of the luckiest members of the fan club we possibly know. But first, everyone knows that DevExpress has great desktop controls, but their web tools are just great. They have this collection of HTML5 JavaScript controls called DevExtreme. And at the heart of the product line are these really powerful and big controls like grid, chart, pivot grid, tree list, and scheduler. But DevExtreme also comes with more than 50 touch-optimized client-side controls, data visualizers, navigators, editors, lists, dialogues, and notification controls, and general-purpose controls like a filter builder, range slider, file uploader, scroll view, and more. And since they're all HTML5, JavaScript, CSS, they include integrations with things like jQuery, Knockout, React, Ionic, and Angular. Plus, DevExtreme controls come with ASP.NET MVC and ASP.NET Core wrappers, so they're infinitely flexible. But don't take our word for it. Go for a test drive at dx.netrocks.com.
All right, buddy. Who's our winner?
Today's winner, Richard, is Scott Newson.
Congratulations, Scott.
Yeah. And it's on its way to you, sir. Scott just won the D Experience subscription, a big pile of awesome from our friends at DevExpress, just for being a member of the .NET Rocks fan club. And if you'd like to join the fan club, go to .NETRocks.com, click on the big Get Free Stuff button, answer a few questions, and join the fan club. We have thousands of members all over the world, and every show we like to give away stuff from our sponsors. And every December we give away a $5,000 technology shopping spree to one lucky member of said fan club. But you got to sign up to win. And we like to ask our guests, of course, Yuck.
Yo.
Yeah, I got $5,000 to spend on technology. What are you going to buy?
Ooh. A really cool, what are those things called? The
Back scratcher.
Back scratcher.
No?
Got it. How'd you know that?
No? Something else?
I don't know. I'm thinking about a security system right now.
Okay.
But I want it to be tricked out with IoT.
All right.
Smart
cameras and sensors.
Smart cameras and sensors. And I had a flooded basement twice.
Uh-oh.
Yeah, it gets old fast.
Yeah.
That thing like fear to motivate you. So I want sensors.
Ask me how I know.
So you want humidity,
I wish I had
sensors.
I should have a cooler thing. I want an engine to a rocket ship.
Oh.
But I don't think that's $5,000.
They're not $5,000.
No.
Well, it depends if it was a model, you know.
Just a little one.
A model
not
one.
too big.
What's bigger than D? E?
But
those.
It is true that the new new security systems all have cloud stuff in them. Like, it's interesting that it has penetrated the regular mortal.
Yeah.
You know, that you really can actually.
You go to Costco now, or you go, there's all these great solutions.
The wife talked me into this place up the coast, and so I had to do a new security system for it, for insurance and stuff.
And now you have Otter Entertainment.
And I have Otter Entertainment. Yes, the Otters are down there regularly. But, you can arm and disarm with your phone, and you can check the cameras remotely. We don't have this on the house back in the city, right? So now she's sort of looking at me like, hey, why does our security system at home suck so much? The Coast place is so good. I'm like,
we have like the geofencing. That's so cool.
Exactly.
I do. I have that at the studio now. I have doors that I can unlock with my phone from anywhere in the world, and I have cameras I can turn on. So
pretty compelling.
What's interesting is I was out here in Seattle, and it's 1:00 in the morning, and I get a text from the landlord, and it says, "Hey, do you have anybody right now in the studio? Because I got a noise complaint from a neighboring building." I go, hang on 1 second. I look, all the doors are locked, and then I pull up the cameras, and the studio's empty. I say, nope, I guarantee you there's nothing going on.
I got video of nobody's in there.
Yep.
That's pretty cool.
It is pretty cool. All right, Andrew, your turn. What are you going to buy with $5,000?
Well, Paul stole my answer. I'd like to, Alexa doesn't control nearly enough stuff in my house right now, so...
Electra, shut off main power. I love doing that.
Of course, it is dangerous because I have a 5-year-old who's smart enough to work Alexa, but not smart enough to know the consequences.
Yeah.
So
it's a tough combination.
Have you got the whole turn all lights off?
Yeah.
That's why she doesn't control as much stuff as she could right now.
Yeah.
Like 2 years ago when he was 3, we were staying with my cousin, and I walk in the door and I hear Alexa going, "Would you like me to sign you up for blank?" And we're no. He was just talking.
Your order is on the way.
Yeah.
We would like to send a big rocket engine to you for only $50,000. Yes or no?
Isn't that how Jeff Bezos bought Whole Foods?
Yep. Buy something from Whole Foods.
Yeah. One of my
Buy Whole Foods. Okay.
One of my adult friends is a nut, and he bought an entire table saw with, just got it that day. That blew me away.
With Alexa?
Yeah.
Wow.
Real-time ordering.
That's a little dangerous.
Living in the future, and it's owned by Jeff Bezos, clearly.
Oh, my
goodness, the darn. Well, and Alexa and Cortana made out on stage this week.
Oh, yeah, that's right. They were talking to each other.
And
they were having verbal intercourse.
There you go.
Yeah.
It's all about the Azure tooling for voice.
Cortana runs in Azure.
That's true.
Yeah,
that's true.
Yeah, and needs to, for that matter. It's all part of the process. What about the debugging aspect of this? Like, I think that when you get tangled up in container behavior and so forth, like, actually understand what's going on, it's got to be a non-trivial issue.
Yeah. Couple dimensions to it that I've been thinking about recently with my team. So one is a lot of times you're dealing with microservices and distributed apps. That in itself is a whole bunch of complexity that comes with it. And we talked about transaction tracing and all those kind of goodies. In addition to that, then you've got with containers, there's clusters, right? And there's things like controllers and nodes and pods that are like kind of wacky infrastructure, and things come and they go, right? So like understanding the exact state something was in at the time, what images, which versions, it could get pretty crazy.
Right. So
that adds almost the next level of, how do I get insight into the state of the system when a bad thing happened?
Yeah.
Right.
And am I in a known version? But the cool thing is with containers, there's usually better DevOps, right? But people, oftentimes we see they've got a pretty nice DevOps pipeline, continuous delivery and things like that that go with their containers. So I'm seeing people be very smart and say, well, the health just got pretty bad with my app running in containers, but I can pinpoint right when it's happening, there was this release, right? And then there's usually monitoring that will say, hey, this release isn't healthy, let's bounce it out, right? So you're almost able to auto-heal some of the problems.
That's cool.
A little bit better.
Yeah.
I also think that just that configuration of code mindset means you tend not to get in really unknown states, so you tend to just tear stuff down and rebuild it, so you kind of know what's going on.
You used to exactly just, okay, shoot it down, it's cattle, and come on back.
I haven't had enough practice with this, but it was one of my favorite experiments and trainings, like the art of a really great website was continuously upgrades.
Yes.
Like was being able to roll out the new version of the website while people were still on the website, not losing shopping carts, like that whole effect. And it strikes me that containers probably rock at that because you've decomposed things more, so you can upgrade pieces as long as you've done integration testing across them, and it's not hard to build a new pod and then just swap traffic over to it and let the old one die.
It's almost like, with stateless computing, PaaS or IaaS, you get a little bit better about understanding your state should really be externalized.
Yeah.
And you want to treat that different than your app code.
Yeah.
Right?
Yeah.
And so you can keep your data there as you just, shoot down the actual app code over and over and over again. So that's pretty
is that
cool.
sort of, a pit of success kind of like you just can't do dumb stuff with state. Because you just lose it immediately.
Yes, pretty quickly.
Remember when you had state?
Yeah.
You don't have it anymore.
It's like an installer with bugs. Like
right away.
Quick.
Speaking of that.
The thing that's really keeping us pretty busy right now, a couple of things with containers. So one is there's an expectation that, of course, the ecosystem of containers will run well in Azure.
Yep.
And also that you can diagnose them. And it turns out there's a lot more tech out there than we had previously worked on. So for logging, maybe FluentD is a really common log shipper, right? Or Telegraph. And, there's a lot of languages that are used together, Java, Spring, and Nginx, Node, and all these different stacks. So it's like, how do we make some of our really magic features work well with all these stacks that are constantly evolving? So I think
without having to inconvenience the developer.
Without having to inconvenience them and say, hey, like, you can get good diagnostics if all you have to do is re-instrument and change everything about what you're doing. Other than that, it's easy.
It's
right. Well, and the IDs that we were talking about, the concurrent IDs?
Yes.
Is that what they're called?
Yeah, I call them correlation IDs.
Correlation IDs. So those just slide down. You don't have to pass those. You don't have to change your
That's right.
signatures.
And we want to keep that being automatic.
Yeah.
So what
but
we're
that's
looking
as long
at,
as it's your services. As soon as I'm inserting my function or my service or anything like that, I've got to respect that correlation ID, I presume.
Yes, although it is automatic using in .NET.
Okay.
Right.
So .NET just realizes that there's a correlation ID coming in.
Yes.
In a path, and it doesn't matter whether you add it or not.
And we put that deep down into .NET itself.
It's in there. Okay.
Which is good. So that's almost a catch-all, right?
So it's almost like an aspect-oriented kind of move because
wait a minute,
you made a call through .NET.
If I'm making a REST call and I don't specifically pass it, does it get passed?
Yes.
It does.
Yes, because what Paul's saying is when a request comes in, in the code that initially handles it, it sets on that thread, right? So it's transient in memory. Yep. And then anytime you do anything and inherits that, if you make a REST request, it's going to embed it in the HTTP header. And then when that request arrives on the other side, it's going to read it out of the headers if it finds it.
So it goes in the header, even though you specifically say what headers I'm sending, and you might have the length and all of that stuff. Doesn't matter. It's going to change it.
It's going to add it
in there.
It's going to add
It's
it
an
in
appender.
there.
Yeah. Are you having an allergy to that? Or are you okay?
No. It's really a good thing.
Okay.
I love that because I ever see it.
Yep.
You know, when I pull the request out, I don't see that it's there. I don't worry about it when it gets sent, and it just happens.
You're going to need a fiddler or something to actually see, hey, there's more.
And that's exactly right.
Yeah.
That's a postman, fiddler, all those kind
of
things.
I love that.
No, and I've been in a situation where that goes wrong. I'm not saying your guys' stuff goes wrong, where there were tools like a load balance something that modified a header. And so we're looking at the header that we sent, and we're not getting the behavior we want. And it's not until we inserted a sniffer, post device or what actually arrived to go, why is this header different?
This is spooky. Yeah,
what is this
it's a bug
thing?
On us if it goes wrong, and
it should never
we're going to fix it.
So here's
correlation ID can probably not hurt anything.
Yeah, it's okay. You have to be listening to the same exact hash that we emitted or
Seems
something
unlikely.
like that.
So here's a weird thing.
Yeah.
Tell me if this exists. Breakpoints in an Azure function?
Ooh.
Yes, absolutely.
Really?
Yeah.
Groovy.
So you can debug them both locally on Visual Studio, or you can remote debug them into App Service. Assuming they're .NET.
Yeah, okay. So is there any .NET code running on Azure that I can't put a breakpoint on?
We don't support debugging into containers remote debugging into containers from Visual Studio at this time.
All right. But that's something on your...
If you won't throw something at me, I'm putting up my blockers. We've done a lot of things with a snapshot debugger to kind of handle...
You do love your snapshot
I do,
debugger,
I
don't
know.
you?
I've got to pedal my wares a little bit.
Yeah, okay.
Because remote debugger, super handy, right? Because you could just attach to something, get to the truth fast. But the bad thing is, like the word breakpoint, you are breaking the process in a server that's bad.
Snapshot debugger, just tell us what it is.
Snapshot debugger, long story short, based on triggers or conditions that you set, an actual process dump, an actual process snapshot will be created by the operating system.
Yeah.
Happens in about 10 milliseconds. It's shelved to the side.
Nice.
The service and the operating system keep running. So now it's still a healthy service, just a very quick snapshot. And that's saved off to Azure.
Yeah, okay.
And you can get to it any time. And it's also correlated using all this fun correlation stuff. So now when there's a problem or something interesting happens, you actually have a debuggable mini dump to go with it.
So I don't have to console.log got here? I don't have to do that?
No,
Is that what you're saying?
do. You still need to do it.
Signal art of the browser. For you,
I would recommend
you keep doing that.
Paul has actually added logic into the tool.
Yeah. If Carl Franklin, then.
And please stop changing your email address.
We know them all.
It doesn't matter.
So bad. So bad.
We'll find you.
You used to have to do that in ASP, in an ASP page, because this logic got so convoluted, you just had to write, message box show or whatever.
Message box show. You should never
super
get
ironic.
here.
I remember that I didn't understand debuggers, and I was total printf style dude in my student days, and now.
I think one of the things, since it's .NET rocks, we get really lazy with an awesome debugger in .NET. I remember when I was in university, it was all C++ console apps and Linux, and GDB is just so painful that most of the time printf was far...
The shivers.
You only use GDB if you couldn't figure it out from printf.
You really needed to debug it bad.
GDB is your debugger.
Yeah. How much do you hate yourself?
I think going back to your original question, so we're making sure that snapshot debugging works in all of these places because it just seems more favorable to this kind of live
real-time stuff
cloud, whether it's production or it's just real-time, like you're saying.
And again, you get in unreproducible situations, right?
Right.
I mean, I'm not going to say it's a downside of the cloud, but the reality of the cloud is that you don't actually know the conditions that your application was actually operating under at the time.
Right.
And there's going to be a certain number of unknowns. And we've certainly seen this on the .NET Rocks side. It's like when SQL Azure does a maintenance cycle, sometimes it causes a hiccup on the site.
Yeah.
And you get messages from Insights and so forth, like you can see all that. But we don't own that stuff. We don't really know what's going on with it all of the time. And so it's useful to be able to not play that unreproducible game. How about just give me a copy of what happened?
Yes. And now you can also decide I want to see when this happens, go give me some debugging for it, right?
Sure.
So
now, if Cortana can explain it to me, now you've got something. It's like, okay, I got this log. Now what happened?
what happened?
What
Discuss.
was that about exactly?
Yeah.
Yes.
We've not talked about Docker at all. We've talked about containers, and I kind of feel like when you only talk about container orchestration, never really go back to Docker, which is kind of the root of all that. Is there anything new in Docker, or does it just work now?
It works really well. I love all the updates that have happened in Docker for Windows, so that you can run in your Visual Studio and .NET environment just more seamlessly. Really cool thing. It's easier than ever to switch between Windows and Linux containers, and we even have the option in our tooling to kind of quickly pick which one will be used. If you watch, I don't want to speak for Docker, but there's cool things I'm seeing as a user going on in their alpha channel. So there is Kubernetes support that's starting to show up there. So that
in Docker for Windows.
In Docker for Windows,
Yeah.
The Windows one looks like it's still coming, but in Docker for Windows. There is some Kubernetes support. So today, if you want multiple Docker containers, you use Compose. And as we talked about,
Compose
Kubernetes,
and Swarm,
Swarm and Compose go together.
But those were the Docker tools.
But now you could actually send a Kubernetes manifest and start on Docker for Windows.
Yeah,
So
okay.
That's pretty powerful. Can you think of other things that are interesting?
One of the things that we're doing
we did a cool thing too.
shipped 15.
It's been a long week.
Is we've gotten rid of the need for the Docker Compose project. And if you're working with a single project in Visual Studio, which one of the things I do in my other part of a job where I'm not working with Paul is my team owns the .NET CLI and .NET Core SDK.
Right.
And so the Docker Compose project had always tripped up building solutions as part of the .NET CLI. And so by removing the need for the DC proj, or the Docker Compose project, we've actually now made Dockerized projects much more compatible with the .NET CLI as well.
Yeah,
very good.
Visual Studio is very strict and ornery about nesting of things. Like solutions and projects need to be at the right order or things go a bit haywire.
Yeah.
So just not even getting into that realm is good. Another thing I've noticed is if you've just got a simple web app, and now you add Docker support, you'll just get the Docker file. And the cool thing is it starts so fast because you're not loading all this extra overhead to actually orchestrate it. You're just saying Docker run, here's my Docker file, boom, up it goes. So, and then you get the cool loop where then you can publish it straight into, let's say, Azure App Service or AKS, and off you go. So just a rapid loop you just fly through using Docker.
That's awesome.
Yeah.
Can I tell a story too? It's kind of interesting.
Please.
Docker, very interesting, kind of brand strength, very, very compelling. So I think, were you there when we did this? We usually ask people who's using containers and who's developing with containers today? And
Paul's pointing at Andrew, by the way, when he says we're you.
Sorry, Andrew.
We can hear that. We can hear that.
But anyway, you heard that. So we're looking around and people are kind of looking at each other. Just a couple hands sheepishly go up. This is odd. Who's using Docker? Oh, hands go up.
Right.
And so I think the general concept of containers and just that in the vocabulary hasn't picked up as quickly as Docker has.
Yeah.
Kleenex or facial tissue?
Yeah,
right.
Kleenex or facial
Sure.
tissue. So it's just an interesting anecdote.
It is interesting. Yeah. What people think.
Yep.
Yeah.
So
what's new? What's next?
What's new?
After
What's
build?
next? Yeah. So we talked about containers. There's a lot more to do. Container diagnostics, that working better with Helm, I think is a big one.
I think for the next quite a few months, it's taking all of our stuff that people showed on stage related to Kubernetes and making it real so that people can use it and it's part of the product.
Right.
Yeah.
Dev spaces.
What's happened with Service Fabric?
Yeah, Service Fabric. So yet another happening this week.
Right.
So if you check out the session on Service Fabric, they unveiled this idea of Service Fabric Mesh. Did you guys get to check that out? So there's a mesh service.
Another name for Fabric.
Yes.
That's another.
We're running out of English language words to describe the same thing.
This one, I would totally check it out.
Okay.
Especially, so Service Fabric, when I think about it, it is awesome for writing microservices.
Right.
It's an awesome runtime for describing stateful applications and all kind of the rocket science problems that come with that.
Right.
Even though I'm not going to get my rocket engine.
Oh, well.
Anyway, so it's super good for that, but Service Fabric wasn't for the squeamish, right, in the past.
Right.
So in Service Fabric Mesh, the application model is so simplified. It's really nice. You just kind of say, I want these containers, I want these ports, and you're off to the races. The second thing is it just works with ordinary .NET apps.
Wow.
Right. So if you're used to writing a .NET app and you want to use something like a stateful, reliable collection, like effectively writing to memory with that kind of a speed and having it replicated everywhere, it's incredibly easy. Just bring in a NuGet and use the reliable collection. And you didn't have to have a new base class there and kind of re-architect your app to get that benefit. Just do it in any .NET app. As long as Service Fabric's there, it's going to run that way. To me, that's
huge.
Freaking awesome.
Yeah, it is. I mean, you just took away a whole bunch of setup and configuration.
And the guys at the booth, they were showing me some really cool stuff. So like one scenario was they showed SQL data, and it was PostgreSQL just happened, but they were writing that to the reliable drives, the reliable state of Service Fabric, and it was just lightning fast and replicated by default. So they took an existing app, they used that technology and Postgres, they didn't rewrite it at all, they just kind of binded to the reliable state in Service Fabric, and they modernized that whole thing. Wow. That was super cool. They showed WordPress doing that too.
Yeah.
And just to kind of paint the imagination of everything you know about .NET and Windows apps, you can do some freaking cool things now.
Sure.
In a distributed system.
Wow, that's great.
So I would check that out, and we made pretty cool tooling for it, so you get F5 and publish and all the goodies.
Oh, that's awesome.
Yep.
Well, Paul, Andrew, thanks a lot. It's been a pleasure talking to you today.
Likewise. It's my first time on the show. I'm so excited.
I know. It's crazy.
I
went to add him as a guest, and he wasn't in the database. I'm like, what?
How's this true?
How did that happen? We've done all our talking, you know, and just
it's okay. I've been on the .NET team since 2000. If you want to, you know, it's never too late.
Really going to try and guilt us on that, are you?
You're never right.
Give that a shot.
All right, thanks. Thanks, guys.
Thanks, guys.
And we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Pwop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1. Recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got transmitter banned by the FCC. Yes, I'm a type of